And welcome back, Mindsetters. I hope you had a nice little break there. You went to do whatever you had to do. You spoke to mom, you spoke to dad, you were on the phone, you got off the phone. Now you're paying attention, you're ready, and you've got your notes out. Make sure that you have your pens and make sure that you get on the page and get chatting to us. If you have any questions, if you have any ideas, if you have any diagrams you'd like to share, make sure you just feel free to post it up on the page because it is for you guys. Think of it as like a backup study notes helper. But on that note, this is where I hand over to Mr. Lou. Lou, take it away.
Cool. Hopefully you're back. Now, what I've done is, I just want to go over the slide. We haven't seen it yet, but it goes over the same thing. You must remember with modification, okay, it's actually easy. It's very easy. But they ask you the simple things like homologous, analogous. They ask you the big names. Where's the radius? Where's the ulna? What does this one do? Why is that one adapted for that? That's the most important things, right? Now, here we go. If we look at homologous structures, it shows us evolution, okay? It also tells us that there was a common ancestor, okay? And you're going to come to me, it's through adaptive radiation. Now, that does not mean Spider-Man and spiders biting you and you start shooting out webs. No, it's not that. Okay, let me tell you what adaptation actually is. Okay, now, I explained it to you with a horse, okay? But it's very, very important to get to the point where adaptation is making life easier for yourself. Okay, so let's say these horse, right? They were still little Jack Russells, okay? The ones that had, because everybody's different. If you look at us, our hands are bigger, some the hands are smaller, some pinkies are bigger, some pinkies are smaller, right? All of those things. If we had a look at that, if we were running on all fours, right? If the pinky was in the way and we had to run very, very fast, okay, what happens is the pinky gets in the way, it's grabbing on the ground, and everybody that has a shorter pinky can run that much faster. And because they run that much faster, okay, they get away from the predators. The guys with a pinky are getting eaten, okay? And once they get eaten, that just leaves me. Right? And everybody that had a short pinky or little bit short, but slightly, and you must remember this happens over millions of years, right? The shorter pinky, everybody with a short pinky, they start breeding, okay? And their children come out with that pinky just even that much shorter than mom and dad. And they survive even better than what my generation did. And after a while, as we're doing that, the pinky gets shorter and shorter and shorter and shorter and shorter until there's nothing left. Okay, so that is how adaptation takes place. Okay, if we had a look at it, there was a nice question the one year in the grade 12. Here we go, grade 12 question paper. It's all about the thorns on a cactus, right? They never used to have thorns, and now all of a sudden they have thorns. The reason they have thorns is because they adapted. Okay, they've adapted because these animals started eating them all the time. So now they put thorns on to protect themselves. Okay, so the ones who had thorns survived, the ones without thorns didn't. There we go. There's a quick adaptation for grade 12. Okay, but you need to know that anyway because they can ask you that. Okay, what does adaptation mean? How do we adapt? Very important. Now, if I go back to the next one, okay, analogous. We haven't gone through analogous at all yet. Okay, analogous is quite cool. This is what we see every day. You walk outside and you see it all the time. Analogous means it's a different ancestor, but does the same function. So if you look at it, you've got your moths, you've got your birds, you've got your bats, you've got your all your insects. So you've got the bee, you know? So all of these things, they all do what? They all fly. So if we have a look at it, analogous means they have the same function, right? But different, what are they called, structures, different structures. So let's see, the bat, look at it, it's all, there's all the what's names, all the blue, forget about the blue, okay? All I'm talking about is, see it's got the 5 fingers, there's its fingers, and it's got this leathery part, wait, I should use a pen, it's so much easier. They've got this part, right, there it is, but they've got this leathery part between each of them. And that leathery part actually grabs air and moves it up and down, right? It moves in the air to use it, right? We go to a bird, right? It's also got the same as this, exactly the same structure there, exactly the same structure, might have changed, but look here. Now it's got feathers, okay? Feathers are light. They push air the exact same way, okay? Just a different mechanism of flying, okay? Different mechanism of flying, very important, okay? If you have a look at this one, can you tell me what that is? It's quite difficult to see what that is. Anybody know? This here, let's go to this one. This one first, okay? This one is your moth. Your moth, it's joined over here. These are mostly veins. They've got a very, very thin epidermal tissue, okay? That's why they can break very, very easily, okay? They break very easily. And then you've got this structure, okay? It is also, if you look at it, there's the bones running across and up and down. It's also adapted for flying, okay? All of these are just different ways to fly. Very important. Now, if I have a look, quick summary of it, just of this, and then I'm going to tell you about couple of things that I don't have on here, but I thought I'd just throw it in for the fun of it. Okay, let's have a look at the summaries here. Okay, homologous or homologous, that's the real way of saying it. Homologous is the top one. So you've got the hand, you've got the bird, you've got the porpoise, which is a nice one, and you've got the elephant. All of them, same structure, different function. Okay? So all of these have a different function, but the structure is the same. Okay? Analogous, okay, that means it does the same function, but it has a different structure. Okay, so we've got feathers and we've got a thin epidermal layer that actually moves there. Okay, so that is a very nice diagram. Okay, if we carry on. Now, before I get to any further, what I want to talk about, okay, is we don't just have this or all of these structures in vertebra. Okay, we also have them in insects. Okay, it was very nice. I didn't think I would get to this, so I'm going to try and get to it as quick as I can so that you can understand it. Now, your insects, okay, if you have a look at your insects, they've got the mouth parts. Now, each mouth part actually changes, okay, to do a function. So, if you look at the grasshopper, right, in the grasshopper, you get your maxilla, you get your mandible, you get your labia, and all of those. Those parts are to bite food. So you get your labia and your maxilla, which actually hold food, and then you get your mandible that actually cuts the food and breaks it up for it to swallow, right? Now, from that was the basic structure. Now, these are homologous, okay? Homologous structures. So you get your homologous structures where they adapt. So then you get the mosquito, that the proboscis starts coming out and it can stick into you, okay? Their mouth parts actually changed, even though it's still got the maxilla and the labia and the, I'll think of the name now, but the top of the mouth, the top palate, right? They come out and they actually suck out the blood. Then you get your butterflies, beautiful butterflies, right? They've got the proboscis that actually turns up and they go get the bottom of your flower, you know, the nectar and all of that. They suck up that. All of this stuff comes from the exact same place, right? They start off the same the same structure, but they change, right? They change to adapt to their own simple function. Okay, so that is your insects. Do you know that plants actually also do it? If you have a look at your plants, right? Each plant wants to make sure that their pollen gets sent to the exact same plant, right? If they have the exact same plant, they can't interbreed between different species. So what they've done, plants are they're actually very clever. You might not think it, right? But they're actually very, very clever. If you get this plant, it only wants to mate with the same type of species as is, even though it can mate with any of the others, but it doesn't want to. The yellow one wants to mate with a yellow one. Just put it like that. It doesn't want to mate with a blue one, right? Now, I'm just using colors instead of their big names, right? So what actually happens is the yellow one, you need a bumblebee, right? A huge bumblebee. Now, a bumblebee is actually a big bee, okay? The bumblebee will land on this flower, and the minute it lands, it actually opens a door because the bumblebee is so heavy. So it opens a door, the bumblebee can go inside, it can take all its nectar, right? And it'll fly away. Once it's got it, as it goes in there, the pollen rubs on its back and on its feet and everywhere like that, and then it leaves. And if it goes and lands on another yellow flower, the thing pops open and this bumblebee goes in. Now, if a bee lands on there, a normal bee, an African bee, that little latch won't open. The bee is not heavy enough. Okay, so if it's not heavy enough, that is not going to pop open. So then the butterfly, this bee will leave. Okay, now but on the blue flowers, this African, they land on it and they fit perfectly. The stem is nice and soft. So the bumblebee lands on there and it can handle the normal bee, right? The minute a bumblebee lands on the blue flower, the flower just breaks off, or it disintegrates. Not just disintegrates, or it bends and the bumblebee can't get in there. Okay, that is the way flowers change so that they don't interbreed, which is quite cool. They also make sure that they do it at different stages of the year so that they don't interbreed. That's another one that looks so good. Also, they change the type of flower so they can make the flower nice and long. And if it's long, then you get the animals with a long beak. So you get your sunflowers and all of those guys. They go in and they get the nectar, right? If they go in and get the nectar, the pollen will land on their beaks and that, and they'll go to the next flower and they'll pollinate it like that, right? So that is how flowers do it. Okay. Now, homologous structures, okay, they all have the same. So they've got all their different petals, and they've got the parts that attract the animals, and they've got the what's that stuff called, the nectar and the pollen. They all got the same type of thing. Okay, but some are for different functions. Their pollen goes for different functions. So you've got the pollen that goes with wind. Now they're going to have big fluffy things to go in the wind. Okay, you're going to have the ones that stick to animals. You've got the ones that have to go with water, right? And they're going to have flagella, so it can move in the water. So it happens with every single thing that we have. Okay, these things will actually adapt to survive in its environment. Okay, hopefully that helps you. Ta.
Yes.
Do we have any questions for today?
Yes, we actually have a couple. More of these questions are more just clearing up. So we might
That's
have to
perfect.
backtrack a little, but I hope you
That's
don't mind
100%. That's why we're
that.
here.
Okay. So basically, first off, we have a question which comes in from Zubuya Erasmus, who's a regular on the page.
Nice.
Zubuya wanted to find out what is the exact function of phalanges?
Of phalanges. Okay, your phalanges are what you actually grab with. Okay, if we look at us. Okay, remember that the phalanges, when it comes to bats, the reason that the phalanges are there, it's a couple of bones away from each other, so you can actually get a nice. If you look at the bat, they get that film between it, and if you open your phalanges, it's going to push more air. That makes more surface area. Okay, now if you have a look at, you can't say, yeah, you can. If you look at good swimmers, they've always got big feet, right? They've got big feet. It's like flippers. Right, the big feet in there, it can move in the water quite nicely. If you look at your hand itself, you can actually see the little piece in here between your phalanges. That piece there is what extends to for the bat all the way to the tip of the phalanges. And if they're closed like that, they can't do anything. If you open it, see, it pops out nicely. That's why when you swim, you're swimming nicely. These things open up everything, or they fly, they open it up. It gives it space so that these little leathery parts can actually move water or move air or anything like that. The phalanges are there to open up and to create big surface area for some animals. It's there to hold on for others, as we found out with a monkey. Okay, it's there for digging. When we come with a mole, it goes in. It's not just a certain part. When we get to the horse, remember with the horse, it used to walk on soft ground, so it opens up so that it doesn't sink into the ground. The minute it starts going into the grassland, those things are not working anymore, so it makes it into one. That's why it has 1 foot. Well, one toe that it runs on, which is its hoof. I hope that made it very clear. Hey, Tom?
Yeah. Okay, so I think what we're going to do is we've got a lot more questions still coming in. Zubuya then also wanted to find out, basically, have baboons adapted the same way as monkeys, basically? That's what she wanted to find. Well, they wanted to find out.
You know what? We can always have a look at this. Adaptation is very strange. Okay? You adapt to your environment to make things nice and fun and to survive. So, for example, if I had to take why, I don't know if this is the right way to do it. I always do it with my boys because they always ask me, black and white people, right? blacks, they come from Africa. It's hot, it's solid. Their skin is adapted for the hard sun, right? They've got dark eyes so that they can use their eyes, they can adapt the sun. If you look at the white people, they come from the areas where it's very cold, so where they've got the ice, okay? The ice is there, they don't need the dark skin. And if you have a look at it, us as South Africans, okay, our skin is darker than what those people come from overseas because we're used to the sun. Our skin is adapted, okay? So we've adapted to other white people, right, because of what we used to, okay? If you have a look at our eyes, my eyes are green, and the reason my eyes are green, what the real reason for having green eyes is that if you're in the snow, okay, it bounces off and into your eyes, the sun. The sun rays bounce off and into your eyes. It's protection, right? Where the dark eyes, they don't need that protection off the light. That's why you can get such bad eyes at times. Depends on the darkness of your eyes, how bad of a reflection that you can take. Okay, so I know that you asked about monkeys and baboons and all of that, but you must understand that it's environment that changes an animal to what it does. Okay, so if there's more trees, if it's in a huge forest, they're going to be more type of an animal that's always in trees, okay? And if it's on the floor, they'll run around. Okay, so hopefully that helps you. But anyway, Ta?
All right, so Mindsetters, on that note, thank you for joining us, and this is where I sign off and say cheers and see you next time.